Alright, what's up everyone? This is LeetCode 876, middle of the linked list. So this problem has a very similar approach to a problem we've done before called linked list cycle. And if you remember that problem that we've done, or you've done it before on your own, um, the approach to this problem is very simple. And before I even go into this problem, this is the second problem that we've encountered that we're going to use the basically the same technique. So I think this problem is, if you've done the linked list cycle problem, this problem is really good at showing you how you can solve problems you've never seen before using techniques that you have used before, right? And so really, I think this problem is a great demonstration of how problems get easier over time once you kind of build up these techniques for solving LeetCode problems. Okay, anyways, so we're given the head of a singly linked list, and we have to return the middle node of the linked list. If there are two middle nodes, we have to return the second middle node. So here we have 5 nodes, right? The middle is the third node. Here we have 6 nodes. So when we go to the middle, right, 3 and 4 are the middle nodes, but we have to take the second middle node, so it'd be 4. Okay, and so when I say we have to solve this problem similar to the linked list cycle problem, what I mean by that, of course, is we're going to use the tortoise and hare algorithm, right? AKA the slow and fast pointer technique. So yeah, so we're just going to call our slow pointer S, and the fast pointer F, and we have to set both of them to the head node, right? Because that's our starting point, and we have to get to the middle of the linked list. And so really, what we're doing here is by the time this fast node, so the fast node is going to traverse this linked list twice as fast as the slow node. Okay, slow node's going to go once, and the fast node is going to go twice per every quote unquote iteration, right? So they both start at the head, right? For this first example, they would both start at 1. The slow node would go 1 forward, the fast node would go 2. Okay, now next iteration, the slow pointer would go 1, and the fast pointer would go 2, so it'd go from 3 to 5. Okay, now we've reached the end of the linked list for this fast pointer, and you can see by the time we reach the end of the linked list for this fast pointer, the slow pointer should be at the middle, which makes sense, right? Because if the fast pointer is traveling twice as fast as a slow pointer, when the fast pointer reaches the end of the list, the slow pointer should be at the middle, right? Because the fast pointer is traveling twice as fast, right? Intuitively, that should make sense. Okay. Example 2, right? Slow pointer here, fast pointer here, both start at the head. Okay, slow pointer at 1. The fast pointer is going to jump twice, so it's going to be at 3. Okay, next iteration, the slow pointer is going to go to 3, and the fast pointer is going to go from 3 to 4 or 5. Okay, now the slow pointer is going to go once, and the fast pointer is going to go 1, 2. Okay, so really there are two conditions that we should check for our fast pointer that should kind of terminate our loop, and that is if the fast pointer is at the last node, or if it's null, right? If it's one to the if it's the fast pointer can either be at the last node, or it can be last.next, which would be a null node, right? Because there is no node. So if they're at either of those, then we should return the slow pointer, and it'll give us the correct answer. Okay. So we're gonna say while the fast node exists, right? And fast.next exists. We're gonna say s is equal to s.next, and f is equal to f.next.next. Okay, and then we're just gonna return s. So let's go over this algorithm. Okay, let's go over these examples again using this algorithm. So let's pay attention to f, right? Because really that's what's gonna terminate our while loop. So f is here initially. It's gonna go .next. Okay, it's at 3. Then .next. Now it's at 5. Okay. While f, that is true, but f.next has to also be return true. But f.next is not going to return true because there is no node here. So So when the fast pointer is here, we're gonna exit and return the slow pointer. We did 2 iterations to get there, right? We went from 1 to 3 and 3 to 5. So at that point, the slow pointer is gonna be it's gonna go from 1 to 2 to 3 in 2 iterations, and so we're gonna return 3. That's gonna give us the correct answer, right? All right, now let's go for example 2. So the fast pointer is gonna go start at the head node, move twice, okay? It's gonna go from 1 to 2, 3, okay? While f and f dot next, well, f is 3 and f dot next is true because the 4 does exist. So we're going to go f dot next dot next. So we're going to go from 3 to 4, 5. Okay. While f, yes. While f dot next, yes. So we're going to go boom, boom. And now f dot next is not going to, f is not going to return true. So we're going to exit. Okay. So how many iterations did it take us to get to here? It took, right? 2 to 3, that's 1 iteration. 4, 5, that's 2 iterations. Then 6 to this null, 3 iterations, right? So 3 iterations. So but at that point, in 3 iterations, our slow pointer should be 2, 3, 4. And see, when we exit the while loop, our slow pointer is going to point at the second node in the middle of our linked list when there's an even number of nodes. So you can see that regardless of whether we have an odd number of nodes or even number of nodes for our linked list, this solution is going to return the correct node at the middle of the linked list. Okay, so we're gonna run this. Yep, that works. Now we're gonna submit, and that's gonna work too. Okay, so yeah, this problem is really good at showing you, again, if you've done the linked list cycle problem. If you haven't, you should go do it. Very similar approach. This problem is very good at, assuming you've done the linked list cycle problem, this problem is very good at showing you how certain techniques for problem solving can be used in future problems that you've never seen. And you know, when you build up these techniques over time, it gets really easy to solve problems that you've never seen before, right? And you start to struggle a little bit less and less over time as long as you keep practicing and not just copying solutions, but making sure you actually understand them. So yeah, I hope this was helpful, and I'll see you in the next one.